all of you are very fine, staying at home and staying safe. We have almost come to the end of our course. We're left with just presentation layer, which we'll be completing in today's lecture. And after this, we would have application layer. As was decided that this week we'll be having our quiz. So day after tomorrow, we'll be taking our first quiz. It would be a multiple choice question based paper. Hopefully it will be timed as well. For that, I would require you to go through the layers up to network layer and including network layer. You would have to read about it. You would have to try all the numericals also associated with it, like we have done in the assignments as well. 20, 30 questions. Accordingly, I'll be sending you the link before the exam. Raman, is everybody registered in the Google Classroom? How would they get informed then about the exam? Because these marks, yeah, I can ignore them, but these marks would be added. So I won't be taking any, I mean, second redo of it. Yes, there would be another quiz, but then both of them would have separate marks and would be added. And let's start with today's lecture. That is about the presentation layer. Regarding the presentation layer, if we go from bottom to up approach, the presentation layer forms the sixth layer of OSI reference model protocol stack. From top to down, obviously the second layer. Now it is different from the other layers that we have come across. It is different from other layers that we have come across with respect to certain. That is firstly, that it has very limited and very specific functions other than the other layers. That's why again this is an optional layer. That's why again TCP IP protocol reference model would take this along with the other along with the application layer. So TCP IP would have combined session, presentation, application into one layer known as the application layer. And also it is easy to describe because it has very much limited functionality. The second thing that is, since it's limited, it's specific, so it is used much less often than other layers. Like I mentioned, optional layer. And in many types of connections, it is not required at all. So coming to it, what does it actually say? Presentation layer. The name should by itself give you the meaning of what we are going to study. So presentation, its main function is presentation. It deals with presentation of data. How do you show the data? So it would deal with the issues with respect to how one system looks at the data and how another system looks at the same data. So representation of data in one system and representation or viewing of data in another system. It takes care of that so that it's understood at both the systems. Okay. In case there is some processing that must be done to the data, when the application tries to send it over the network, it will take care of that. Okay. So in simple terms, we would say that presentation layer would define the format in which the data is to be exchanged between the two communicating entities. Let me just annotate it here. So it defines the format in which the data is to be exchanged. This is the primary thing that this layer is supposed to do. Then, as the slide here says, that it takes care of syntax and semantics of the information exchange between the communicating systems. So, presentation layer here takes care takes care that the data is sent in such a way that the receiver will understand the information and will be able to use that data. So the two things that come across here is syntax as well as semantics. So syntax, like languages can be different in the two communicating system. Now what would the presentation layer here does? Presentation here layer would be responsible to communicate in that language which that system would understand. As an example, Ramanan speaks Telugu. Okay, I speak Kashmiri. If I need to speak, if I need to communicate some message to Ramanand, I would require a person who can speak Telugu as well as Kashmiri. So he will take my message, convert into Telugu and pass on to Ramanand. And Ramanand in reply would say his message in Telugu itself to that person. And that person would translate to me in Kashmiri. So this person would act as a translator. Okay, so this is what presentation would layer would do as a main function, that it would translate between multiple data formats using a common data format. And also this presentation layer would be concerned with preserving the meaning of information sent across the network. What I mean by meaning of information, I'll be coming to it in a little while. But as of now, keep in mind that it translates between multiple data formats using a single format, and also it is concerned with preserving the meaning of information sent across the network. That's like it would encode, it would decode, and so. The presentation layer also manages these abstract data structures. What abstract data structures that we have? Because to make it possible for computers with different data representations to communicate, the data structures to be exchanged can be defined in an abstract way. And presentation layer here manages these abstract data structures and allows higher level data structures like banking records to be defined and exchanged. That is where we said that it's concerned with preserving the meaning of information sent across the network. It does encoding and decoding. So this is the introduction that we have of the presentation layer. So we are clear with what it does. It's simple, it's limited, it's specific, it's used much less often, because at times presentation of data would be same, at times you might not need encoding and decoding, and at times you might not need some security features. And the specific functions that we come across with respect to the presentation layer is, the first one is data format, which we write here as data representation. The second one that we have is, I mean, translation comes within this data format or data representation as well. The second one is data compression. And the third one that we have is security and privacy, which is mentioned here as encryption. So let's take with the data format. The first issue with respect, the first function that presentation layer does is about data format. Let's try to understand this. You know that networks can connect different types of computers together. What I mean by different types of computers, we have laptops, desktops, we have PCs, we have workstations, we have supercomputers. We have Windows-based PC, we have Linux-based PC, Unix-based PC, Macintoshes, Unix systems, AS400 servers, we have mainframes, and all these different devices. Nowadays, we have, Android-based devices, uh, Mac OS-based devices. There are plenty of different operating systems, plenty of different computers that connect to the same network. And these systems have many distinct characteristics. They have different characteristics and they represent data in different ways. That is the point that we have here, is that each system that is connected here would represent the data in a different way. For example, they may use a different character set. This is where the presentation layer would help. And presentation layer's job would be to handle these different data structures, different data sets, and it would create a certain abstraction. And what abstraction would be here? It would handle the job of hiding these difference between the machines. If you're connected to a Mac-based OS and you are working on Windows-based OS, you're still able to communicate with it, even though they may be using a different data structure. They may represent different data in a different ways.
Hello, sir.
What data like strings, integer structures, etc. They may be represented in such a way that you would need somebody in between, okay, to format the data that is being exchanged. Here in the slide, you can say, how many bits does an integer contain? Are you using an ASCII or abcd character set? This is where data representation comes into being. For the latecomers, I need to approve them to join the meeting. It takes me some time here and class gets disturbed. So coming back to the data representation here. So if two dissimilar computers are to exchange text, say email, they must agree on the representation to be used in the exchange. So one must translate from or into the agreed upon representation. Another example, we just said whether ASCII or whether ABCD. How do we encode letter A? One popular way to use is a 7-bit number, that is 65, right? So this is where the data representation comes. What would be the syntax and semantics? One complement, two's complement representation, data structures, strings, integer structures, and so on. If there are any special processing that is to be done, this is what we mean by data representation. And the presentation layer is supposed to take care of it. Popular data representation is ASNI and XDR, where ASNI is an ISO standard and XDR is used with Sun RPCs. This is the first thing That is data representation. And with this data representation, I just now gave an example of whether your system uses ASCII or whether your system uses ABCD. If I am using ASCII system and you are using ABCD system, now I am supposed to send data to you. I would do some encoding and you would do some type of encoding, which we call as character encoding. Like on an ASCII system, if I have file containing the bytes 108.97.110, for ASCII system, it means LAN. Let me just add this slide here. So this is about encoding what I am discussing here. If I have bytes of 108.97.110, okay, and I am using ASCII system, this means LAN on an ASCII system. The same thing 108.97.110 on ABCD system means this percentage sign, a forward slash sign, and a greater sign. So what does it mean? It means in ASCII, right, 108 is L. In ABCD, 108 is percentage sign. So different systems would have different data formats. This is an example by which you may be able to understand. This is what we call as character encoding. And the representation problem that is what we have here with respect to data representation is that you have to ensure that this file reads the same on any system. If I have sent it as LAN, on your system this should not come as percentage forward slash and greater than sign. The bits are same, the zeros and ones won't change. It's just that our representation changes, our interpretation changes actually rather than our interpretation changes. Okay, so this is where the presentation layer would help. However, these days most people have more or less settled on ASCII based system as the encoding method. So to use for simple Roman letters and digits. So presentation issues are minimal for these kind of data. Then we have other things as well. That is the character sets of different languages, Chinese, Russian, and so on. We still have that. We have universal character set, UCS, as well, universal character set, which is again one of the common character sets have been used, UCS. I hope the first part is clear, what we mean by data representation, the first function of it. The second thing that we have is data compression. We compress the data. Now, what do we mean by data compression here? Data compression is like, you have to send some data to me, right? I have recorded a lecture of 1 hour, and one of you takes the important points and takes out some redundant parts from the video and compiles it and makes the summary of the video in such a way that nothing, whatever I have said, is lost and sent across. So what was the earlier recorded lecture was of a bigger size. Now you have comparatively smaller size. So sometimes your programs need to send more of a data in a timely fashion, but we do not have that much of bandwidth that can be supported. Like for example, when you see a live stream, okay. Now, if two of you are watching a cricket match online, let's take an example of a session here. One of them is watching the same match from the same subscribed channel, is watching an HD channel, but another one is watching at a very low quality of 140, 360 and so on, the lower two, let's say 240. But both of them see the match, both of them see the bowling on time. Now what is the difference here? You will say the difference would be with respect to the video quality or image quality. So what is the difference? In HD, the quality is good because compression method has been used. Different. Whereas in the low quality that you have transmitted here, compression is a lot. Your bandwidth is less, but you get the multimedia in a timely fashion. This is what we call the fair share of bandwidth on a congested link. So you require to get a good throughput, to utilize the bandwidth of the network in a way, you would require that the data from the sender to the receiver should be compressed. That is why we need. In terms of networking, we can effectively increase the overall throughput by compressing the data from the sending end to the receiving end. And there are two ways by which we can do the compression. The first one is a lossless compression. The second one is lossy compression. In lossless compression, you compress at one end and decompress at another end. The loss of information. You preserve all the information related to bits, that is bit preserving, or this is also known as reversible system. The second one that we have is a lossy compression, wherein you would lose some of the information. Okay, this is most suited, the lossy compression is most suited for video and audio compression techniques. Another point that we come across in data compression is that since we know that presentation layer is in end systems, it is not available in any of the intermediate nodes like routers, switches, hubs, and so on, which come in between the sender and the destination. So this is a protocol which is an end-to-end protocol. And if compression and decompression is done at the two ends, right, it would save a lot of time. There is no use of, compression and decompressing at every node in a multi-hop network. If it's done, generally it is done at the point of origin, that is compression, and decompression is done at the destination. This would be done by layer 6. There is the compression methods that are done by the lower layers also, which you would have studied in data communication, wherein layer 2 would do some compression mechanisms. But Layer 2 compression mechanism is done when we assume that layer 6 is not doing any compression. And what advantages would be getting because of compression? If we do end-to-end compression, we would have less memory requirement for intermediate nodes, that is buffers. There would be lesser packets to be handled by the intermediate nodes. They would take lesser time because compression means smaller packets, smaller time for transmission. Okay. And this would overall result in better response time, better throughput, and also it would be less cost. Here in the slide, there are examples of compression, which is image, audio, and video. Before this, I would like to mention that we can have two main types of compression. The first one that we come across, frequency dependent compression. And the second one that we have is known as context dependent compression. Let's take the first one, that is frequency dependent compression. Also known as statistical encoding. Now what it means? It means, as an example, letter E occurs approximately 100 times more frequently in English text than does the letter Q. So we can do a lot of compression if we have a character encoding scheme wherein the more frequently used letters take up fewer than 8 bits and the less frequently used letters can take more than 8 bits, like E and Q in this example. The only problem is that the computer, when receiving these string of bits, must be able to determine where is the beginning and where is the end of character. This would be easy only if they have all same size. But there are a lot of character encoding techniques which take care of this. The example that we here, which you have done previously, is Huffman coding. Now you get what I'm trying to explain here. The second one is context dependent coding. And what is context dependent coding? The first one is the frequency dependent, is like you would have E more commonly seen than Q, whereas the context dependent coding here means it recognize that some letters, some characters, some bytes often occur adjacent to one another. As an example, just think of a word which starts with Q and does not have U after it. Is there any? Queen, Q, quotient. I mean, whatever comes to my mind starting with the alphabet Q, it would generally have U with it. Another example is T. T is often followed by H, the, there, those, and so on. Thus, so context depending coding recognizes that some characters bytes often occur adjacent to one another. I'll write it here. Some characters oblique bytes often occur adjacent to another. Q and U. Another example is T and H. Now, because of that, by knowing this, we might be able to assign a code to QU or Q to QH, which is shorter than 2 bytes, which may be longer than the Huffman code for a given letter, but shorter than 2 bytes. And the example for the example for context depending coding is the run length coding. Known as RLE, run length encoding. This is one example that we have, and this is another example that we come across for data compression. Now let me take an example of what type of compressions do we generally see here. We have compression of data, we have compression of images, audio and video. This is a slide which shows how image is compressed, what format we have like GIF, GIF, that is graphics interchange format. What type of compression is it? Is it lossy or is it lossless compression? What are the methods that have been used and what is the usage for it? Like for artificial images and support animation. These are different image formats generally or popularly used: BMP, JPEG, GIF, PNG, TIFF, and JPEG 2000. Then we have audio compression mechanisms. Okay, again, there is a lossy audio compression and there is lossless. When it's lossless, we have an exact copy of one's audio file. And when we have lossy, there are some irreversible changes that happen to the acoustics of the audio stream that we have. Typically, it happens in streaming. There are different codecs which have been used, like MPEG-4 ALS is a lossless audio compression. MP3 MPEG-1 is a lossy audio compression mechanism. That's why the sizes would differ. In one case, you might find that in a lossless, we have a file of 10-15 MBs, and the same audio, if you listen, maybe you may not be able to perceive the difference by just listening to it, but there would be a difference in the size with respect to, let's say, 10 would make just 3 MB with respect to another compression, that is the lossy compression. Then Dolby Digital, all the examples, I mean, there are some examples which have been given here. Below here you can see codecs in lossy as well as lossless, that is here. This is the lossless examples. This is the lossy examples. Why would require lossless? Why would require lossy? Obviously, for having a good quality audio, for saving, preserving it, you would want to have its original copy without any loss. You don't have any memory issues. You do not require it for streaming. Keep it in a good format. Whereas streaming it, there are requirements with respect to bandwidth, throughput, and so on. There should be lesser delays. Okay, like you're streaming a live match, you're listening to it. So you would want that everything should be timely. Then you do not worry about the exact quality of it. You can degrade quality to somewhat level, acceptable level. This is where we require the lossy audio compression. Then we have different video compression techniques here are mentioned here. Again, because of these, you would have different formats of MPEG and so on, by which certain qualities, like you have HD quality, on the other hand, you have poor quality with, certain pixelization issues that you might see. And the third and the last fund that we'll across with respect to presentation layer, the role of the presentation layer is the security and privacy issues. Again, we come to the example of presentation layer where we say that presentation layer is an optional layer. Why? The reason that the presentation layer is not always used in network is that it may not be needed at all. Like you are compressing some data. If your data is small, why would you want to compress the data and send it across? You'll say, okay, I will save on bandwidth. But the cost in terms of, let's say, time and so on, that you will take in compression would be more than what time it would have taken for you to send it across. So you may not need compression at all in sending some data. That's why maybe for video you need compression, maybe some data that you're sending may not need compression. It becomes optional in that case. Likewise, for security encryption, okay? For encryption, maybe your data is so common or your data is not, it doesn't require any security at all. Why would you add security to it? Why would you add some overhead in encryption and decryption of data when you actually don't need it? Again, becomes optional. When the format of representation in the sender and the receiver is same, why you need overhead in translation? Thus, all of these become optional, in which in certain circumstances you might require, in other circumstances you may not require the help of these what you call presentation layer. Also, some take this as part of application itself. So application would take care of features like presentation and so on. Okay. So you, as an application, as an OSI layer part, presentation layers function may be skipped by the protocol stack implementations. I hope this part is clear. Let's take the last part of it, that is security and privacy issues. Now you need to send information across the network which nobody else should be able to comprehend, or nobody should be able to take that. For example, there is some information which you secretly share with another person. Let's say there's a trade secret and so on. You know that your network can easily be wiretapped or somebody can eavesdrop and listen to it. So what you do, in order to prevent the unauthorized insertion or deletion of message or listening of the message, you encrypt. You change it in a certain form using an algorithm, and you have a secret key. You send it across, send the key separately, send information separately. Now the receiver receives this information and receives the key. With the help of this key, he unlocks it, which means he decrypts the message using a decryption algorithm. And this key would uniquely decode that particular sender's encryption. This is where encryption, decryption, cryptography, authentication, digital signatures, these all things are taken care by presentation layer. There are some issues with respect to encryption, like who does the encryption? Should data link do the encryption? Should presentation layer do the encryption? Okay. However, with respect to security, we would like to have end-to-end security. We can leave this to the presentation layer to perform encryption of data, because we would have end-to-end encryption with respect to this. So this is what I just now explained with respect to encryption and with respect to the decryption. So this is me, sender. This is the recipient on the other end. Okay. Now, when I say hello, I want this message to be received as hello by the recipient, but in between, nobody should be able to see this message as hello. So I use an encryption, and this hello gets changed into percentage FD dollar JH. What it is, the person who's eavesdropping, who's trying to see this message cannot understand it, because I need to decrypt what this message is. So at the decryption end, using the key that I have separately sent, this message can be translated into this. So the general idea here with respect to encryption, description, cryptography is to modify the data so that it is meaningless to the observer. The middle one, the green one, that is percentage FDES, is meaningless here. But the intended destination or intended receiver knows or is able to decrypt it, and nobody else in between understand what this message is. So we have protocols which take care of it. The most common protocol of the presentation layer is SSL, that is Secure Sockets Layer Protocol. Now there might be a question that like other layers, do they do security as well? Yes. If you remember, when we did IP, we had IPsec, that is IP security. So not all the encryption decryption would be done, or not all the security features would be added by the by the presentation layer. There are some lower layer protocols also which take care of security. As an example is IPsec, that is IP security. Is this clear? Do we have any questions? Ramanand? Yeah, I took a bit of long time. So than what I was promised, but we're done with this. Okay. Now we're left with the last layer, that is the application layer. So we'll take it after the quiz. Is that fine? All right. Any questions? Any questions regarding your quiz? Platform, I'll be informing you. All right. Choose a platform in such a way that they should be, easily accessible. Hopefully not issues with login and so on. Marin says, please keep it easy. I mean, that I can't promise. I mean, you would have to study it. Okay. There are I'm planning to have it 30 questions, 20, 30 MCQs. It would be mix of both. So I won't promise it to be easy or promise it to be difficult. Some questions is like you just read it and answer it. Some questions you would need a pen and paper to calculate the answers. But I'll for sure try it to be timed one. I don't want it to be open. So you would have time there. I'm trying to have a randomization of questions as well. Let's see how much successful I'll be. Right? If you have any doubts, you can please email me, please message me, please WhatsApp me, whatever is comfortable to you. Okay, I'll be there to answer your questions. Good amount of time, that I will not promise. I will give very less amount of time. And you know the reason why I'll give less amount of time. Akif, that's the answer for you. There won't be reasonable amount of time so that I minimize the chances of passing on the information. So, so rather than making the question difficult, I'll try to have it in such a way that you do it in a fast way, in a lesser time. Read it, practice it. That would be my answer. All right. Since these quizzes are added, so I would suggest you take this seriously. Anything else? Okay, then we'll end our class. Ramanand, I'll see you in the next class. Please, everybody, you be on Google Classroom, all right? If at all, I'll share the link. I'll like 5-10 minutes before, if I have to share the link, I will put it up there so that everybody gets it. So that I'm not told that I didn't receive the message and so on. Right?